all about humanity. About humanity.
What is electric current? Being concise, it is a flow of electrons in a circuit. In picture 1, we can observe a simple circuit. It is a lamp connected to a battery using a copper wire. An electron flow comes out of the negative terminal of the battery, cross the lamp, and enter into the positive terminal of the battery. The electron flow keeps the lamp turned on. If we remove the battery, the electron flow stops and the lamp gets turned off. Now, how does electron flow work? To explain this, we need to remember some physical concepts. We all know that matter is made up of countless tiny particles called atoms. And atoms are made up of electrons, protons, and neutrons. In picture 3, we have a copper atom. In the nucleus, it has neutrons and protons, and in the electron shells, it has only electrons. In the first shell, it has 2 electrons. In the second, it has 8 electrons. In the third, it has 18 electrons. And in the last one, it has only 1 electron. This electron is special. It is called free electron. The difference between this electron and the other electrons is that the other electrons are tightly held to the atom, but this electron is not. This means that this electron can be pushed away with little energy, and this is what makes copper an excellent conductor. If we zoom in the copper wire, we can observe the atoms in the circuit. When the battery energizes the circuit, the free electron jumps from one atom to another atom and then to another atom, and they keep jumping as long as the battery keeps energizing the circuit. This constant electron jumping is what we call electron flow. If we remove the battery, this jumping stops. In engineering, we don't usually talk about electron flow. Instead, we talk about conventional current flow. This convention pretends that positive charges are moving in the opposite direction of electron flow. This is, it moves from the positive terminal of the battery to the negative terminal. To explain this, let's check what happened between atom 1 and atom 2. When this electron jumps from atom 1 to atom 2, the atom 2 gets charged negatively and atom 1 gets charged positively. We can say that negative charges are moving to the right and positive charges are moving to the left. The same thing happened between atom 3 and atom 1. When this atom moves to atom 1, atom 3 gets charged positively. And all the same thing happened to all the atoms. Electrical formulas work regardless of which theory is used. This means that our calculations are going to have the same result regardless of which flow are we using. The current unit is the ampere. The ampere is equal to 1 coulomb per second. A coulomb half the charge of 6.5 times 10 to 18 electrons. When we say that in our circuit is going 1 ampere, this means that this amount of electrons are moving each second. From now on, when we talk about currents, we are referring to conventional currents. If we want to talk about electron currents, we are going to use the word electron currents or electron flow.